sixth experiment in System Software and Compiler Lab. The topic is single pass assembler for SIC. So the aim is to simulate the concept of single pass assembler for instructional computer. So let's go to the program now. So you have this files that are to be imported. Java.io.buffer reader and Java.io.buffer writer, and also file reader and file writer and IO exception, one of these things packages. And after that we have this public class assembler, is the main class, and we have this main of function which is stores file not found exception along with the exception handler. And also here we have a file reader fr is equal to new file reader of the assembler.txt. So first let me show you those text files. So here assembler. So this is the main file which consists of the coding of it starts starts from it, and LDA starts from it, and after that the LDA command, then STA command and the beta, and STA command gamma, then also reserver and reserve byte, these, and the rest of the text files are intermediate generation. And next is the output. This is the last one, and the sim table. This is for the symbol table which has those values. This is the address, and the sim table consists of those alpha, beta, and gamma entries. And after that we have let's go to the program now. So first we have those assignments for buffer reader BR, so new buffer reader off. Then totally there are 4 buffer readers, BR1, BR2, and BR3 and BR4. For each things, each file takes like assembler.txt, then for optable.txt, then for intermediate text.txt, and sim table. And also we have buffer writer for it, and buffer 2 buffer writers. 3 buffer writers for intermediate, then sim table, and output. And for having this, we are declaring a string, then string line, and optable was null value. And while if the string x is equal to br2.readline, that is that buffer reader2.readline not equal to null, then it comes into this. And if optable is not equal to null, then the optable value is x value is assigned to the optable. Else the optable is equal to that's concatenated with the value of the string along with the x. So after that we have this n is equal to 0, then location counter, then length is equal to 0, and start is equal to 0. That's the initial starting state. Then we have the while line is equal to br.readline not equal to null. Then the string words line split up, that is each words are split up. Then after that we have int I is equal to 0. Then if line dot contains a start, if it contains start, so like in the assembler program we have the first line as a start. So if the line is equal to start, it goes in, and if the I is less than words dot length, then if words of I is equal or equals start, then it goes in, then it assigns the value of I to n, and I value is incremented. Then after that, if words dot length is greater than n, the location the words are converted into integer. They're using the parseInt. Then finally the location counter is printed out. Then else the location counter is equal to 0. Then start is equal to location counter. So the value of location counter is going to the start. Then the buffer writer function is being called, and also the new line function. So then after else, then I is equal to 0 is being initialized, is given. Then another j is equal to 0 is being declared and initialized. Then string is equal to string opcode is being declared, variable is declared. And after that, while I less than words dot length, if optable contains words, so if the optable contains words, then string of op is equal to this object which is being created. And while j less than op dot length, so the object code writes the opcode into it. So for that, the main thing is the optable contains these object codes, the STA and LDA. So this is the function being carried out here. So let me check over here. Then after that, if those things are then location counter is incremented by 3 because word value is 3. And after that is the j value is incremented by 1, and also I value is incremented by 1. So the next condition is if the line contains word. So if the line contains word, according to this, if the line contains word like this, it's being some will do in the accumulator, I mean assembler. So after that the location counter is increased by 3 since it's a word, and if it's a byte it is increased by 1, and if it contains a reserved word then it's increased by words into 3, it's a thrice thing, and after that if it's a reserved byte contains any reserved byte and it's words of it gives only 2. Then if the length is equal to location counter start, then this function is being executed. So if the sim table is null, so it's actually the sim table. So sim table. So if the given sim table, if the given sim table is null, then the preferred thing is being carried out. Then after that, word start line and input and the split function is being carried out. Then if the symbol table is okay, the words is equal to line dot split off. Then if the line contains start, then these words are written to it, and there is a BW3. This is the third variable that is being declared, or else the words are the output is being desired output is to be printed. So let me run this file. So this is the output, and so the final output is over here. There is from those values of the symbol tables and words is being printed out over here, and these opt tables for storing those outputs, the intermediate tables for storing those addresses and the words and values of it, and the assembler which contains the program codes, and finally we have this output. That's all. Thank you.